Today, we're going to pull back the curtain on a tiny, almost hidden feature inside every single Bitcoin transaction. It's a silent guardian that lets a multi-billion-dollar network completely reinvent itself without blowing up. I mean, think about it. This is the big, high-stakes question, right? It's what keeps Bitcoin developers up at night. Any little change, any new rule could have absolutely disastrous consequences if it's not handled with surgical precision. It's kind of like trying to upgrade a jet engine while the plane is in mid-flight with the whole global economy on board. And you'd think the answer would be some super complex thing, but it actually lies right here, in this incredibly simple detail. The very first 4 bytes of any transaction define its version. The original was, of course, version 1, and for a long, long time, that's all there was. But as you're about to see, this little number holds the entire key to Bitcoin's ability to evolve safely. Okay, so to really get why this version number is such a game changer, we first have to understand a very specific and pretty dangerous problem, this ticking time bomb of what are called pre-signed transactions. So what in the world is a pre-signed transaction? Well, the easiest way to think about it is like a post-dated check, but for the digital world. You create it, you sign it, authorizing a payment, but you don't send it out to the network right away. You just store it, maybe for months, maybe even for years. And this isn't just some theoretical thing. It's a critical part of how more advanced applications like the Lightning Network actually work. And here's where things can go horribly wrong. Imagine this. A user creates a perfectly good transaction. They put it away for safekeeping. But in the meantime, while it's just sitting there, the Bitcoin network gets an upgrade. New rules are introduced for what makes a transaction valid. So when the user finally goes to broadcast their old transaction, the network just rejects it. It's not valid anymore. The consequence isn't just some annoying error message. It is catastrophic. Because if you can't create a new valid signature, maybe you've lost the private keys since you first made it, that money is just gone forever. This was a massive problem that the developers absolutely had to solve. But this is where our unsung hero, that tiny version number, swoops in to save the day with a solution that is just, well, incredibly elegant. The fix is actually shockingly simple. When developers introduce new rules for the network, they don't apply them to everybody. They just tie them to a new version number. So all those old version 1 transactions that people have stored, they just keep on following the old rules, completely unaffected by the upgrade. The new, tougher rules only apply to transactions that say, hey, I'm a version 2 transaction. Now, the first time this was used in a major way was with an upgrade called BIP68. This was a soft fork, which is just a fancy way of saying a backward-compatible upgrade. It introduced version 2 transactions and applied a whole new set of rules to a field called sequence, which unlocked all sorts of new capabilities without putting a single one of those old pre-signed transactions at risk. So what you have here is basically a system of opt-in complexity. The network can add new features and new rules, but it does it in a way that never breaks the old stuff. It's like it grandfathers in every single transaction ever created under the old rule set, protecting them from any changes that come down the line. And this powerful idea wasn't just some one-time fix. No way. It became the fundamental blueprint for how the entire Bitcoin protocol evolves and adds new features safely. It's really what ensures its long-term survival. In fact, a very similar signaling trick was absolutely crucial for arguably one of the biggest, most important upgrades in Bitcoin's entire history: segregated witness, or as you probably know it, SegWit. It needed to introduce a whole new transaction format, which could have been a network-splitting disaster. But this clever approach saved the day. But it wasn't a disaster. Here's the genius hack they used. In the old format, there's a specific byte that represents the number of inputs. Now, since a transaction can't have 0 inputs, they use that 0 value as a kind of secret handshake. When new software sees a 0 there, it knows, aha, this is a new SegWit transaction. I need to look for extra data. But the old software, it just sees a transaction with 0 inputs, thinks, nope, that's invalid, and just ignores it. It's another brilliant backward-compatible hack. So, that brings us more or less to the present day. But the story of transaction versions is far from over. It's still a really active part of Bitcoin development. So, what's next? Well, as we speak, there's a widely considered proposal to start using version 3 transactions.
And this time, it's not really about adding a major new feature. It's about changing network rules to make the whole system tougher against certain kinds of denial of service, or DOS attacks. Where someone tries to spam and clog up the network. The evolution just keeps going.
So let's bring it all home. Why does this tiny 4-byte number at the start of every transaction matter so much? Let's just quickly recap the key takeaways. At the end of the day, it's the key that lets Bitcoin upgrade safely on the fly. It protects user funds that might be locked away for years. It stops the network from splitting into incompatible factions during an upgrade. It provides a clear path for future innovation. And as we just saw, it can even be used to make the network tougher against attacks. This little number is so much more than a technical detail. It's the mechanism that allows Bitcoin to be both incredibly stable and remarkably adaptable. It is the true unsung hero that lets the protocol change without ever breaking its fundamental promises. It's really a masterclass in forward-thinking design, making sure the network can grow and get better for years and years to come. And it leaves us with a really fascinating question. As developers continue to push the boundaries, what future for Bitcoin will this tiny number unlock next?